So today I'm going to talk to you about scaling observability and tell you a story about continuous growth. I'm going to talk to you about the challenges we faced, the key principles we had, and the lessons we've learned, and what it's like to keep the lights on a rapidly going business, and how we've scaled our metrics, logs, and traces to be on processing 50 terabytes of telemetry a day. So my name is Toomas. I've been living in the UK for the past 6 years now, and the past 4.5 of which I've been working in Wise, scaling the observability platform there. And before moving to the UK, I worked on metrics and tracing systems in Telia, Estonia. So yeah, in general, I've been working with observability systems for around 7 years now. A little about Wise itself as well. Wise is a global technology company building the best way to move and manage the world's money. We're powering money for people and businesses to pay, get paid, and to spend in any currency wherever you are and whatever you're doing. We were co-founded by Kristo Käärmann and Taavet Hindrikus back in 2011 under the name TransferWise. We're one of the world's fastest growing profitable companies and listed on the London Stock Exchange. Some stats about the business. In 2023, we had 10 million active customers worldwide, and we supported around 5% of the personal cross-border payment volumes globally. About 66% of our customers find us via word of mouth, and we support around 40 different currencies, and there's around 5,500 people bringing you the mission. Before I go onwards, I'd like to say that the target audience for today's talk is someone like myself 5-6 years ago, and that's why it's very narrowly focused on the observability engineering event. So if today's content is too niche for you, I hope there's still something you can get out of it. So throughout past 5 years, from 2019 to 2024, we've grown our microservices from a single monolith to now supporting close to 1,000 different microservices. And roughly speaking, that's also the amount of telemetry we get in our systems, the amount of metrics and logs. And going forward, I'll take you to the evolution of our observability platform as it's grown organically and work our way towards where we are today. In our system, the rate of telemetry collection we get around 23 terabytes of metrics a day, around 30 terabytes of traces, and around 8 to 9 terabytes of logs. So in total, we get somewhere around 60 to 70 terabytes of data. These metrics are all based on Prometheus or Kubernetes network in, network out, and some of it is compressed, some of it is not, like the Prometheus ones. Looking closer at our metrics system and its evolution. This is roughly what our metrics system looks today, or what it's been looking like. We have our read path and our write path. So in the Kubernetes clusters, we have a Prometheus instance that's scraping data from all of the services. It's accompanied by Thanos sidecar that takes the data from Prometheus and writes it all into S3. Next to it, on the right path, we have Thanos ruler that reads the data from Prometheus and older data through Thanos store from S3, and again writes the computed metrics to S3. On the read path, we use Querier, so Grafana would access the Querier and get the latest data from Thanos sidecar and older historical data through Thanos store from the S3 bucket. What our Prometheus collection has evolved over time. So in 2019, we had a single Prometheus instance with a replica. In 2020, it became too big to fit on the underlying worker nodes, so we had to shard our service to keep the lights on. So we used our service tiers to shard our Prometheus. We used our tiers 1 to 4 and had shard 0 for everything that was left over. In 2022, we had ran into the same issue again. So in the end, we ended up with 20 different Prometheus instances, scraping the data from the cluster. And doing that, if you look at if you think about the previous slide where we have Thanos ruler querying all of that data, and that data is across 3 different availability zones, that generates quite a lot of cross availability zone traffic. So that is something that the service providers like to charge money for, and something that you may want to think of when you get to that stage. And yeah, the problem with we have with Thanos today is that it wasn't built in a way that we haven't built our system in a way that enables a small team to support the growing footprint of our infrastructure. But yeah, all of that sharding gave us some more time to work on other things, looking at our logging systems. When we talk about logging in WISE, we talk about log analytics, and we talk about real-time logging and alerting. In my mind, it's important to differentiate those two, because sending data to Elasticsearch is much more expensive than sending data to S3 bucket costs. So running our ELK stack or Elasticsearch log/Kibana costs about 10 times what it costs to run that workload on Grafana Loki or S3 in the backend. And that's why I look at Kibana as a premium feature that shouldn't really come as a birthright to all services. And yeah, in terms of logging, this picture is unfortunately still pretty accurate. That supports most of our log flows. We have our collection layer, aggregation in Kafka, and we have different feature consumers that take that data and push it into external systems. In this bit, we're looking at Elasticsearch specifically. So in Kubernetes clusters, we have a Fluent bit daemon set that collects the data from all the worker nodes and pushes it to Kafka, where we collect the logs from. And the problem with this picture is that our clients are directly connecting to Kafka. When we had more clients coming to us and asking how are they going to get their logs from systems other than Kubernetes, the easy thing to tell them was to send their logs to Kafka, but that creates a problem. We're leaking our infrastructure implementation details to our clients. And this was the evolution of what we did afterwards. We created a log ingestion gateway and provided an API for our clients to send data to. And at that gateway, we can make some decisions based on who's sending the data, what kind of features they should be getting, and so forth. But yeah, the important factor or the important aspect about this picture is abstracting away your internals, so you could change what you're doing and change the implementation details, providing the API layer to your clients. Looking closer what our Elasticsearch stack looks like, we're looking at log analytics, is something like this. So with our Elasticsearch, we started off with a single cluster a long time ago. And that grew to a point where it became quite hard to manage and maintain. So we sharded our Elasticsearch clusters as well. So we use cross-cluster search to search between different clusters. And we have around 5 different data holding clusters where we route the search request to. With Elasticsearch, I kind of have a love and hate relationship. I love the product, but when we talk about logging, we always need to scale for the peak throughput. And logging volumes in general are seasonal, so it's not the most efficient way to provide logging to your systems. And Why we need to scale for peak throughput is because when we want to scale our workloads down, we need to destroy nodes, and because we're working with stateful data, we need to move that data around. When we have hundreds of terabytes of data in a cluster, that generates a lot of cross-availability zone traffic when we run across multiple availability zones. And at that point, scaling down your cluster becomes as expensive as just keeping the nodes running. And yeah, with Elasticsearch, a few tips. If you're not compressing your network traffic already, that's an easy win. If you're using Prometheus Exporter, the community maintained one, then it's very easy to DDoS your cluster, speaking from personal experience. So if you're monitoring your cluster from a central location, you may want to think about how you've configured your agent. We can talk about that later if anyone's interested. And yeah, shard distribution matters as well in a cluster to optimize the compute usage. Again, something that we can talk about later. If we look at the real-time logging and alerting application of our stack, like I said, Grafana provides a service that is 10 times cheaper to run for us than Elastic is. And we felt that Grafana, we could keep real-time as well. And basically, alerting on logs was how we introduced it to our stack initially. And after having introduced Grafana Loki, we also had a log server that was basically one gigantic box with lots of disks and was never up to date, but some people like to use it. And with Grafana Loki, we got an opportunity to get rid of that log server and destroy it. So we created a stateless virtual server that had log CLI on it and could query Grafana Loki. Technically, we could allow engineers to query Grafana Loki directly as well, but we are interested in what our users are querying and want to have controls around what is being queried and so forth. So log CLI basically allowed us to get rid of another service as well. So we're reusing our own services. Looking at tracing within Wise. So before I joined, there was a lot of effort put into instrumenting our services. Our services used Jaeger instrumentation to get tracing into our applications. And when I joined, the tracing problems had mostly already been solved. We were using Jaeger agent to push data to Jaeger that was storing data in Elasticsearch. In 2022, we introduced another one of Grafana backend products, Grafana Tempo, next to Grafana Loki. So we're using two different products by then. And with Grafana Tempo, storing data wasn't an issue anymore because we were sending it to S3, which is cheaper to run than Elasticsearch. And at that point, it was easy to tune the tracing dial from 0.1 to 1 and just have 100% tracing. At this point, we could discuss what is the benefits around tail-based versus set-based sampling, but that's something we can do later. So year over year, our telemetry volumes have grown along with our business, 30+% a year, roughly. And the thing we've had to think long and hard about is how to sustainably scale our product. We've thought about how to reduce technical overhead, how to find time to improve the data we collect, because that's a major opportunity, and most importantly, create time to educate our users. So how do we keep up with the successful business? Meet the reliability squad. Observability is the area where I mostly work, and basically we provide the platform for our other teams. Application engineering helps instrument all of the applications that we have within Wise, and SRE provides value on top of what application engineering and observability builds, on top of a few other things as well. They have services. And the hardest part around scaling our product, in my opinion, isn't the technical one. it's being able to deal with the change and chaos that's around us. So on our Grafana, we have around 1,000 users per month, and those users have questions and requests that we need to deal with. We go through continuous audits. We're probably one of the most regulated companies in the world, because how many different markets we operate in as a single company. And then there's always incidents and making sure we learn from the incidents, hiring and ensuring continuity of the team, and external projects that we need to be involved in. So these are all the challenges that we need to face. So this is where we ended up. We will either become a vendor or take our business to one. So whilst it's easy to ship all your data away, if you're generating as much data as we are, then and growing on 30% a year, then sending that data to a vendor would probably cost more than we pay on our cloud bill. So we'd need to sell our CTO an idea that we're going to spend more on observability than we do on AWS. And that's a hard sell to do. And yeah, ideally, we want to enable our users without having to police what data they produce, but educating our users is a very important factor, so they know what's their part of making the product work for them. And this is how we're becoming a vendor, building strong foundations. A mission critical part of this is being available and accessible to our clients. We need architecture that enables us to be available to all our clients where they are. Once we've achieved that, we need to be available and stay available. So we need to build for scalability. So we need to be able to scale horizontally, limit our blast radiuses, be able to rate limit and all things like that. And on top of that, when first two are achieved, we can focus on educating our users and dealing with the data that our systems produce. And yeah, being available and accessible is one of the mission critical parts that will enable us to build our product. This is roughly what our product looks like. So being available where our clients are is existential for us, because if we're not, we need to go and create custom solutions and integrations, and those are very expensive to do because they take time and then someone needs to maintain them. So this means that our services will need to be in a lot of different auditory scopes as well. But this is fine because we keep our design simple and make sure that we have controls at every step of the way to mitigate different risks. And introducing this kind of design, we went through our GRC teams and our cloud team to make sure that everything was good on paper, and create the paper trail where different parties approved the ideas that we had. And yeah, ideally, when auditors come to us, we should be able to show them our design, show them the tests, because we need to test for our controls and the test results, and have them come back with all the questions they have from those. In terms of individual controls, I'm not going to go into those. For building for scalability, once we're available, we need to keep the lights on. And generally, we don't want our clients to come to us and ask how are they going to get their telemetry from system X, Y, or Z. So we don't want to create custom solutions, and we need to be scalable. So in my opinion, the Python ethos has been a key driver behind our design decisions, and making sure that everything we build within Wise comes with batteries included. So if we provision cloud accounts, they should come with a telemetry agent that takes all that data from that specific context and sends it to us. When we provision Kubernetes clusters, we do the same. The clusters come with agents that send us all the data. We do everything we can to make onboarding our clients as frictionless and seamless as possible. And when everything comes with batteries included, we need to be able to accept all the data and keep the lights on. In terms of infrastructure and operational scalability, we need to be scalable, horizontally scalable in all of the collection, ingestion, caching, and querying bits. Luckily, with Grafana products, with Loki, Tempo, and Mimir, these problems have already been solved for us. With operational scalability, we need to keep our stack as simple as we can. So simplifying our stack has a very important role to play in this. So with Loki, Tempo, and Mimir, they all follow the same architecture, and that helps us reduce the operational overhead and reduce context switching when we're moving from one domain to another. And this is what our metrics tracing and logging system roughly looks at what we're building. All of the different domains follow the same architecture, and we use Grafana provided Helm charts to get our services deployed. We use some customization in places where the Helm charts aren't enough, but at the end of the day, we want to keep the code we need to maintain to a minimum, and that is why we use what the open source community gives us. In terms of keeping the lights on and limiting blast radiuses on issues, we've sharded our clients into tenancies, and those different tenancies we use rate limiting on, and we build towards a day where we can start talking about fair use policies and making sure that the clients are actually aware of what they're doing. In this instance, you should be able to see that we're dropping quite a lot of data from the second line item. You can see we're dropping 200,000 requests a second because that's the test environment, and the team that's producing that data wasn't willing to pay for that data, basically. But yeah, for us to be able to reach our mission zero, we need to know what our products cost, and to be able to make educated cost-benefit comparisons and decide if something is helping us to reach our mission or taking us further away. And yeah, borrowing and extending what we get from open source. This is important to keep our operational overhead low. We don't want to copy-paste stuff we get from the internet, because that means that we will need to maintain all of that code. And with stuff like deploying infrastructure, all of these are problems that we all share, and problems that have largely been solved by different people and different companies. And yeah, if we have to build something, we need to be able to maintain it as well. So keeping that things we need to maintain to a minimum has a very important role in terms of operational scalability. And with Grafana and many other CNCF projects, they all come with Prometheus rules and dashboards included. They're called monitoring mixins, and I would recommend everyone to have a look and use them if you can. With Mimir, in this example, we can see that we're getting around a dozen different dashboards for free without having to do anything ourselves. And when we see that there's something missing that it's not offering, we can either contribute back or build on top of the dashboards we already get. And yeah, using these things makes our life so much easier and creates incentives to contribute back to open source and have discussions and contribute our operational experience back. And monitoring mixins is also one of the places I would recommend using JSONnet, because it makes your life easier, although JSONnet itself comes with quite a lot of operational overhead, and be careful if you do decide to go too far. For us, we use JSONnet to make sure that all of our alerts come with the correct context, so that I would have correct links to logs and correct Grafana instance, since so far we've had multiple different ones. We want the links to alerts be showing the right dashboards. And this is just a generic overview of one of our Mimir setups, one of the free dashboards that we get. And this is what helps us keep our operational overhead low. We get free dashboards and are able to use them and navigate throughout our products. And with Loki, Tempo, and Mimir, we're talking about software that comes with batteries included. They come with means of deployment with Helm charts or Tanka, and alerts and links to great runbooks as well, and dashboards that we can link to specific alerts. If we had to build all of that from scratch, it would take quite a lot of engineering effort and operational overhead. And just an example of what a runbook looks like with Grafana Mimir. If you haven't used runbooks or don't know what they are, I recommend looking at that. It's, from my experience, it's the best example of a runbook I've seen so far. And yeah, educating our users. At the end of the day, we're building an APM product using LGTM stack. That's Loki, Grafana, Tempo, and Mimir. And we do not have hundreds of engineers like to build our product. So we need to level up our engineers and have our engineers know what is their part of building that product. So educating our users is the easiest way to deal with the underlying problems we face. And an example around building a product. For us in Grafana, it's important to build a product, not a dashboard. And to make Grafana work, we need to use labeling or tagging, dashboard, make sure that the dashboards query variables and that those variables are named in a way that makes sense. For us, we use DS metrics data source in this example, and that data source is defined there. But you can see from here that we are using the tenancies to dynamically have consistent naming within our metric stacks as well. So if we look at what this looks like in practice, so the user will go to a dashboard, select their tenancy, and have all their or data sources selected for them. Their metrics, traces, logs, and continuous profiling or whatever else data source is. So the client just selects the context and everything else gets selected automatically and is hidden away from the dashboard. So if you change the tenancy, you'll get the right context for your dashboard. And yeah, in our APM product that we're building, we need to know what the engineers need to do to make this vision happen. And thanks. There's really too much to cover in general, like what we've been working over on past 4 or 5 years. But this kind of gives you a helicopter overview of our challenges, the principles we've used, and some lessons we learned along the way as well.